Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Pedro, who has completed the course ROS 2 Basics in 5 days. And this is one of our online courses that we offer, and at the end of this course, you can actually complete a project and implement it on a real robot, and then present it with us. So that is what we're going to be seeing here today from Pedro. So hello, Pedro. How are you?
Hello, I'm good. How about you?
I am good. I'm very excited to see your presentation. So please, whenever you want, you can start sharing your screen and show us what you've done with the project.
Okay, just a second.
Awesome.
Can you see it?
Yes, we can see the robot cameras now.
Good. So let me restart the robot. Let me recompile. And run it. So first it will look for a wall, align itself, and
Uh-huh.
start running and track all the points it goes on.
Okay, so right now it's finding the wall, no?
Yeah. I prefer to use a low velocity to turn it easier to find the wall.
Absolutely, yes.
But even approaching like this, sometimes it doesn't find the wall. It spins 2 times to find a wall.
Oh, okay. So right now it's still not found it, and it's
Yeah.
spinning still. All right.
Yeah.
Um, do we have a? Could you leave up the terminal out so we can see
Oh,
the output
yeah. Sorry.
of what's happening? Oh, nice.
It
That's nice. Yeah.
it's logging the print. It's printing the minimum sensor value. So the sensor is closest the thing that's closer, in this case the wall,
I see.
and the index of this laser measurement.
Oh, so now it has found it. I saw it
Yeah,
go
and
forward,
it's
and now it's still tracking that.
yeah. Now it's aligning
Uh huh.
using the right sensor,
So
and it doesn't find it, but it's strange. Aligning it's not common that it don't find a wall.
okay. So
The
I already have a couple of ideas. Why is
uh-huh.
that happening? And maybe you're only looking at the one index.
No, I'm looking for, I don't know, 10 indexes,
Oh, okay.
but it's still happening. I think to use bigger range, but I'm scared of it doesn't align
So good,
so
yeah. Uh,
yeah.
I think 10 sound like enough. So maybe when we get into it a little bit, we'll see.
Okay. I think it's 10 or something like that for the front wall and less for the right wall
Yeah.
because it's closest the wall.
And let me ask you, well, now we saw that it has
Uh-huh.
started and it's following the wall. Uh, so does this happen every time that it's like on the second lap that it finds it or
No,
not?
no, no,
This
no.
okay. So right now, what are we looking at now at the
It's the
terminal?
odometry. It's
Uh-huh.
the odometry. It's printing. It's the feedback of the action, and
Yeah.
it's feedbacking the amount of distance it's going.
I see.
It's
I
running.
see. And then once it finishes, once it does one lap, what can we expect?
It will stop
It
and
will
print
stop
all the points. Uh-huh.
all the points that it traveled through.
Yes. True.
Okay.
That's some warning and errors that I will explain when I show the
Uh-huh.
code.
Cool.
So it stops. Thank God.
Nice. Awesome.
And this is the list of all the points.
Uh-huh.
It's okay?
Awesome. It's great. Yeah, now that we saw the full project, could you please explain us how you've solved each one
Yeah,
of
of
these sections?
course. So I iterate all over the code sometimes because actually this is my first time with robotics. I never had any contact with robotics.
Mm.
So I don't have any, any idea of nothing. So I've tried different approaches to solve the problem.
Uh-huh.
The following code I change a lot because I started with conditional code. So if the distance is bigger, less, I change the velocity,
Right.
but it's so unstable. And before searching for some things, for some theory, I tried and I achieve something that when I go to search, when I solve it, all the the project, I start to search for theory, math theory, something like this,
Uh-huh.
and I find myself that I I discovered something like the P of the PID, the proportional part,
Right.
and that's what I used.
Oh,
But
nice.
it's only this. I didn't change anything after my research because I liked my code.
Mm-hmm.
So, but it with I sorry, how I like how I only use the P, it oscillates a lot. You have seen it
Yeah, I saw
oscillates
it
a lot.
was, but I mean, as long as it does the lab, we're less concerned about how precise that controller is, and it's actually
Uh-huh.
great that you went.
I
Well,
had some problems with these oscillations
okay.
with the odometry. It was the biggest one.
Uh huh.
So I will start displaying the code and I will explain the details.
Yes,
That
please.
some values are different from the what it was could here. So let me explain.
Okay.
First, the wall finder, the first thing the robot does. So this is a service. This is a service,
Mm-hmm.
and I have two callbacks: the service callback and the scan callback, and I need it to works parallel in parallel. So I need to create a callback group, a entrance callback group, and these two make part of this group, this callback group,
Mm-hmm.
so it can work in parallel.
Right.
And so this is the service callback, and it receives a request, makes something, and returns a response. And this something is it it receives a request and have three while loops. The first while loop is for finding the closest wall. First, this is in actually this is four while loops. This one is because when I start the code, maybe I don't have any laser scams.
Right.
So I need to wait for the first scam callback. And I'm waiting. When I have this data, these readings, I can proceed the code. So the second while loop, it get the this self index that is here. How this works, it every laser callback, I get the mean value, the index of the mean value of the array of the ranges.
Right.
So I get the closest reading. And I attribute this for the in this property of the class, self index, and this self from distance, I get these three readings. Now I'm seeing that I'm only getting three readings.
Mm-hmm.
And I had another problem that I had is that I try to find this sensor index with the math equation that I saw in the course,
Right.
but it I get it, but it's not the right one on the front of the robot. So what I does, I get the robot with the joystick, put it in facing the wall,
Mm-hmm.
and get this value. And with this value, I calculate the another values with the incremental step. And I
Okay.
find the robot more precisely aligned with the wall.
Okay.
So this is it. I get the minimum range, I get the minimum of these three readings, and I save with in self index in self from distance. And I have the distance in the front and then distance in the right. No, the minimum distance in the distance in the front.
Uh-huh.
In this while loop, I see if the minimum value is one of these values. This 386 is the value right in front of the robot.
I
And I
see.
take some in the right and some in the left. That's the one that I told you that I have more than one value
Mm-hmm.
that I compare of. So if the mean value of the readings is one of these, no, while it's not one of these, it means that the robot is not facing the wall and need to continue spinning. And so I on log that is rotating in and say what index it's the minimum of all the readings.
Mm-hmm.
And first I attribute some angular velocity to the to the twist that I'm publishing for the CMD valve topic. And while it's not the front reading, I continue publishing this angular velocity of 1.
Mm-hmm.
And and I publish here in the callback and not in the while loop because I think that I start publishing here, but I had some problems of synchronism
Okay.
because it aligns itself, but the while don't stops and it passes, so it misalign. So I publish here and change the values in the whiles in the another function. So when the minimum value is one of these, it means that the robot's facing the wall. So I change the values. I accent some linear value and zero the angular value. And the second loop, it I get the front reading, and while it's bigger than 26 centimeters, I continue approaching and then stop. This is
Mm-hmm.
the first different value that I'm using from the the instructions. This one is just for the robot goes middle of the street.
Right. Okay.
So it's on this and this the same logic while the robot's not in the position that I want, it continue approaching, and when it is, I change again I zero the linear value and change the angular value for the rotating again and align with the wall.
Mm-hmm.
So this is the third while loop does. While the last reading is not one of these, this 206 is the reading I found that is in the right of the robot. So I think that this reading makes the robot uh, it's right aligning with the wall. And when it facing the wall, approach the wall, and align with the wall, I set this active as false for not publishing anymore because its callback will continue running but I don't want that it publish. And I publish another twist, but without any velocity for the robot stop. and I changed this response while found equals true, and return the response. So this is the function of the service,
Mm-hmm.
and I will use this response if it is true or false in the while following. So I mm, I will explain these and the odometry for the last, okay?
All right. Just be mindful of the time.
Okay. So this is the while following. This is a node that is a topic publisher and subscriber. It's not a service or an action. I have this align function. It calls the service. So when here I had a different approach of the course. I don't use the thread here. I use the thread inside the class to call the method. So right here I spin normally, and in the constructor I create a thread and start the thread with this method for spinning. And this scam callback, it is with all the logic of the code, all the things, it won't do anything while this ready wasn't true. And this ready, it becomes true when the response of the service comes true. I return a response and the response is true, so the ready becomes true right here.
Mm-hmm.
So it aligns, it calls the service and wait for this because it's a sync call. And I attribute the response for the self ready. In this case, it's true. And if it's ready, I start to track the odometry that I will explain. And this method start to do something. So when the robot is aligned, I get the from wall reading. I take a range of the 10, I think that is 10. Oh God, rather. So I take this from reading. That is a range of readings. I get the minimum,
Mm-hmm.
and I get 2 points in the right. So this is the reading the right of the robot, and this one is 60 degrees of this point, and I do some calculation, some trigonometry to find the real distance from the robot from the wall.
Okay.
And I had some problems with this. It can be a num, and one of these readings can be an infinite number.
Yes.
So this explains the try except. This is for the infinite number. If it is infinite, it comes an error here, and I have this except for this. And if it is a num, I have an elif here, and to handle this. So I get the distance from the robot from the wall, and I had this proportional calculation here for the angular velocity. My linear velocity are constant, 0.09, and I verify if it has a wall in front of it, I turn, and I don't care about the right wall. And in second, I verify it is a num or not. And if it is, I take the last value of z and uses multiply it by -1 just for stabilize the robot. I don't know if it makes sense, but my head makes sense. And if none of these statements are true, I set the angular velocity for the z. Here I'm just verifying if it is bigger than the maximum velocity or less than minimum velocity that I defined, that is 0.18. So it's only this what this code is doing. If it is more, and I use the 0.18. If less, I use minus 0.18, .18. And If it's not the case, I use the z that I calculated here.
Okay. You have 5 minutes left.
Okay. Uh, so the actions callbacks, the callback for the first response request, the callback for the result response request from the action, and the feedback that I take the feedback and log it. So I'll jump for the odometry for because the time. Here is an action. So I have the record callback, the feedback callback, and the odom callback. So when I will receive a goal and I accept or not. If I accept it, I become to run this callback. Here I have another reading trans callback group because I need this callback and this to run in parallel. So here I take all the values of the geometry and store them in the class properties and verifies if the displacement is less than this measure here. That is different because it works with the 0.05 that is asked in the instructions, but because of all the oscillation of the robot, it's uh, it's varies a lot. And I found that the robot never will be less than 1, I think, 0.1, if it doesn't have a completed in loop.
Mm.
So I use the 0.9096 because of this, because it's more constantly working. Because and here the callback that tracks all the points. So I have its flags, it's self-recording, recording if I accept the goal, and I append here in this list the first odometry, and I start a loop. So it waits 1 second, and I take the last odometry, save this odometry on the array, and feedback it. So in this feedback callback here, no, here, I do all the calculations, the displace, the total distance that I feedbacking all the time and logging the terminal, and sending it to the client that calls the send me the goal. And I think that's it. In the fast way, but that's it.
Awesome. Great, great. Well, first of all, Pedro, let me congratulate you for a really, really nice
Thank you.
project you've done. Uh, I like how you structured it, and uh, um, I can tell that you have put in the work necessary because of the precise numbers you've entered throughout the code that I've seen. Okay, so
Uh-huh.
I really like that, and it shows that you took the time to really showcase what you've learned in the course. So congratulations on that. Let me also really liked how you handled uh, how you use the logging for errors and warnings. Might
Mm-hmm.
seem silly, but it once you start getting into really complicated programs, it's really helpful to visibly see things like that. So I really like that. Um, so I want to more than more than questions here. I have comments on
Okay.
your solution, which I think is good, but I think there is room for improvement in the following things. So
Okay.
first, we saw the issue that the robot would not stop spinning
Mm-hmm.
until the second lap.
Mm-hmm.
And we asked, well, what if it's looking at one value instead of all of those, So that is actually a a reason. I'm not sure why, but looking at your code, for example, you said I take 7 values and you hard coded them in,
Mm-hmm.
right? What
Mm-hmm.
that means is you actually put the number, you figured out. You said I put the robot in the middle, then I figured out it was 396 or whatever it was. I don't really know, and then you put that in there. So my guess here is that it was a miss. It's a timing issue, right? You're spinning at a point 0.1 angular velocity or something like
Mm-hmm.
that, and uh, the the loop that is checking is not quick enough to catch in between those. So maybe missed it on those 7 values, and that's why it kept going. So
Mm-hmm.
my solution for this is, first, I recommend never using hard-coded values, never using a 360 or all these numbers that you're setting for, and specifically for the while loops, because
Mm-hmm.
those are conditioning whether the code exits or not the loop. So what I would do, because sometimes you'll get a robot with a different LiDAR, right? And it works the same, but instead of 720 or something, it might
Mm-hmm.
have 1,080, right? So you can deal with these with dealing with the lengths of your array, right? In the scan callback, you're extracting the message, and you can take then the length of that
Mm-hmm.
value of that message, and then you can check where the front and where the back is, and divide that over that, right? So the front
Mm-hmm.
is if it starts at the back, then it's going to be length over 2. That's the front, right?
Mm-hmm.
You
Right.
might have other issues which happen to deal with real life. For example, you
Yeah.
said it's not precisely 360.
Yeah.
It's like 371 or something, like
Mm-hmm.
a little bit off. Well, that might be because the lidar is not receiving enough power, and what that means sometimes is that the length of your laser scan array, instead of being 720, it'll be 711, 710 or
Mm-hmm.
something because of that. So then you have to be able to catch this in a real world scenario, and you're going to be more likely to do it if you do like math instead of hard coded values. And my
Okay.
guess is that 7 values wasn't enough. So maybe don't be scared of overshooting it, and then adjusting if it's too
Okay.
much. So that's my first comment on the why it kept going. Okay, and then my second comment. Let's see. I wrote. Yeah, I have 2 more comments. One
Mm-hmm.
of them is, I also do not recommend publishing or doing too much in sensor callbacks. In this case, the scan callback. So you have scan
Mm-hmm.
callbacks in all programs, I think, and then you do operations on the message received. So my recommendation is to only extract the message in the
Mm-hmm.
scan callback, and then you can do other things with it in a different, in a separate function, in a different method. Why is that? Because this callback gets activated every time a new sensor message arrives, and that varies for sensor to sensor, and from,
Mm-hmm.
like, obviously as a robot you want as much data as you can, right? You want all of
Uh-huh.
it to be able to react. And sometimes, maybe if you do a very long scan callback, you don't right here, so it's probably not an issue, but you might get into a situation where the scan callback is processing, so you're going line by line, and then another message arrived, right?
Mm-hmm.
For whatever reason, it didn't finish, so you lose that data. Uh,
Okay.
and then, based on that, I saw you publishing to ROS. I recommend taking it out. You mentioned that it was giving you some issues, but
Mm-hmm.
it's better to remove the publishing from the scan callback, so it's not based
Okay.
on the data arriving. That's my recommendation, because it can get really messy between publishing here, publishing there. Because I saw you publishing in a bunch of different areas, which might lead to confusion. So
Okay.
that's my second comment, and my third last comment is just something little that I noticed, that it's not a big deal, but I think it can lead to confusion. In one of your programs, the you said the front distance is going to be the minimum of these 3 indices, right? Uh,
Right.
and in that, if you think about it, that's not true. The front distance is always the same index.
Uh-huh.
It can you said it can be either of these three, but uh, you're basically telling the robot that it has three fronts, and of course, because there's not a lot of data here, it won't be much of a difference, but it might. So just be mindful of these kind of hard coded values that you put in, and try to handle it like I said in the beginning,
Mm-hmm.
with math half of length, or the minimum is a great way to do it. That you were doing the minimum of the array, the standard deviation, things like that you can avoid saying, oh, like I want index number 300 to be
Mm-hmm.
determinant on this. So that would be my third comment. But other than that, I think your code shows very good structure and, of course, practice and understanding of the three main topics we were trying to provide in the course. So I'm just mentioning these for future improvement, but it doesn't mean that it wasn't a successful presentation, because I can tell that you took your time and performed it correctly, and even if it missed that first spin, it was able to catch himself and finish correctly. And at the end of the day,
Yeah.
that's what you want with robotics. Maybe it misses something, but it's gonna get there. So
Uh,
I just want to congratulate you again, Pedro, and
Thank you.
so really, really nice job, and thank you so much for coming and showing us what you've done with your project. Really, really nice.
No, thank you.
All right, guys. So yes, awesome. Let me just switch back to my screen here. And yes, guys, this is what you can do when you finish one of our courses that offers a certificate. Is that you can come and present the project in order to showcase what you've learned with us and obtain a certificate from us. So I invite everyone to do what Pedro has done here and come over and present your projects. And yeah, that's it for us, guys. Pedro, one more time, thank you very much for your time and your presentation. And guys, we'll see you next time for our next one. All right. Bye bye.